Okay, so I've had a couple students ask me about problem 49 on section 8.8, and I can see why. There are two methods for demonstrating that this given function is a solution of the given differential equation. There is the keep everything in sigma version, and then there's the if in doubt expanded out version. I'm going to demonstrate the if in doubt expanded out version. So if you do this problem by expanding terms, then I would start with what they said y is. So they said y is the sum as n goes from 0 to infinity of x to the 2n over 2 to the n times n factorial. Okay, so expanding the terms just means, plug 0 in for n, and then 1, and then 2, and then 3, and so on. If we do that, we would get okay, so the first four terms, when you start just expanding this function, would be 1 plus x squared over 2 plus x to the 4th over 8 plus x to the 6th over 48. And then, of course, it could continue. Now, if we ever feel the need to come back and build in more terms, we certainly can. But I think we'll get a pretty clear picture with just these four terms. So now let's figure out, well, if that's y, then, what would y prime be? Well, y prime would simply be d dx of, both sides of this equation. So let's take d dx of this side. So d dx of 1, 0, you don't have to write it, I will. D dx of x squared over 2 be x. D dx of x to the 4th over 8 would be, what would that be? X cubed over 2. And then d dx of x to the 6th over 48 would be x to the 5th over 8. And then I found that it was really nice to have the same number of non-zero terms for both y and y prime. So let's just think about what would have come after x to the 6th over 48. And I'm just going to scratch it down over here. So what would the next term have been, right there? I don't want to make it official. I just want to kind of do it off to the side. So let's see. This is from playing 0, 1, 2, 3. So let's plug 4 in. That would have been x to the 8th over whatever 16 times 24 is. How about that? Is that right? Yeah. Okay. And then let's do the derivative of that term and then put it in here. So taking the derivative, the 8 would cancel with the 16, which is nice. So we'd have x to the 7th over, I think, 48. There we go. Okay. Hopefully I didn't mess that up. And then I'm just going to go ahead and erase that because, again, I only did that because it's nice to have the same number of non-zero terms for each of your functions here. So let's see, so now let's build up, so this is y prime, which we'll need is in our differential equation. Now let's multiply it by, and you can pick either x or negative x. Let's see, I'm going to go ahead and just multiply it by x. So x times y prime. Actually, I'm going to leave a space because this is getting cluttery. Okay, x times y prime. Well, that would just be multiplying both sides of this previous expression by x. So what would we have? 0 times x, still 0. Let's see, I'll just say 0 there. And then x times x would be x squared. Why? Weird spacing. Okay, x squared, just multiply by x. X to the 4th over 2 plus multiplying this one by x, x to the 6th over 8. And then the next term would give you x to the 8th over 48. Like so. Okay. Let's see, what else do we need? We also need to know what y double prime is, so let's get that. Y double prime would be, okay, derivative of 0, still 0. Derivative of x is 1. I don't know why I'm putting those zeros in, it's weird. Anyway, derivative of x cubed over 2 is 3x squared over 2. Derivative of x to the 5th over 8 5x to the 4th over 8. Derivative of x to the 7th over 48. There we go. And so on. Okay. So now that I have all the little pieces formed in kind of an expanded term way of all the different parts of the differential equation, now let's build this expression up. Okay. So notice I have y double prime right here, which is very convenient. And the first thing that I would do is take y double prime and subtract xy prime from it. So I'm just going to go ahead and write that. I'm going to subtract xy prime from the left side. And then on the right side, that would look like subtracting 0 plus, I'll try to line up like terms. How about that? 0 plus x squared plus x to the 4th over 2 plus x to the 6th over 8. And then, I think I'll just say plus dot 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 instead of including that next term. Okay, so what do I now have? On the left side, I have y double prime, let me move this up a little bit, minus xy prime. And on the right side, what do I have? 0 minus 0, 1. It doesn't have anything to subtract from, so 1. But we have 3x squared over 2, take away x squared, which would be x squared over 2. 5x to the 4th over 8, take away x to the 4th over 2, would be, I believe, x to the 4th over 8. And 7x to the 6th over 48, take away x to the 6th over 8. Would be x to the 6th over 48. Like so. Okay, so now building, again, we're trying to build this expression up on the left side here of your differential equation. So I'm going to go ahead and subtract y from both sides. So on the left side, it would look like this, and on the right side, it would look like, let's see, what was y in the first place? 1 plus x squared over 2 plus x to the 4th over 8 plus x to the 6th over 48, and so on. Okay, so subtracting the left side, we would have y double prime minus xy prime minus y. And on the right side, it's actually super adorable the way everything just obviously vanishes. And then you've got it equaling 0. And we have just verified that the function represented by this Maclaurin series would satisfy the given differential equation. I hope this is helpful to you.